Hi guys, Mike again, AO Reed. We're at Cal State University Fullerton. This is the new housing building. We're in the main mechanical room on the first floor, building A. We are now transitioning into domestic hot water in this space to cover all of the utilities in this room. We're going to be dealing with our domestic plate and frame heat exchangers. So they're made by ACE water heaters. We have two. They're redundant, but they do run in tandem. So if one needs to be worked on, you'll still have the other one. We have our main power switch right here. So without this on, the unit won't work. After that, this is important that you understand that this HOA manual off auto switch is only for the pump control down here. So we are pumping water out of the bottom of the heat exchanger, pushing it through the heat exchanger at the bottom on the domestic side, and then comes out the top and back into the upper part of the tank. So without the pump running, we won't be making hot water. Okay? And that's controlled off of this switch right here. This switch has nothing to do with the control valve. If you needed to do some type of testing, you can manually turn on the pump. So in auto, if the unit's calling for heat, then the pump will be on, okay? And then the valve will be modulating. If this is in manual, the pump would just be running all the time. It would be a waste of energy. Okay? This tells us that there is power available. Red light will show us up if there's a fault. If one of the sensors doesn't work, we're getting a fault out of one of these two controllers. So these two controllers right here, we have our high limit controller. This high limit controller would be more if you're like high temp water or steam, and you can get into boiling temperatures. The warmest I've ever seen the water come over here is like 160 on the plant. So the set point's 190, right? We should never get close to that. This will always read a little bit higher because it's up higher on the tank, okay? So our high limit controller is the upper sensor over here, and then our controlling temperature sensor is the box down there, which is the lower controller, okay? This is domestic hot water, and we have a storage tank, so we're using 140 as our set point for Legionella, okay? So we want to make sure the tank maintains the 140 degrees to create, to reduce the odds of growing bacteria, okay? Again, so this is our temperature set point. This is our actual temperature. The controller here sends a signal to the valve. Okay? This valve modulates open and close depending how far away from the set point it is. It does have adjusting PID loop. So if it did sit for a long time with no hot water to it, if you're servicing it, you left power onto it, the PID loop is learning that it's not working, and it will make adjustments. So I would just recommend switching off power and cycling power to the unit, and it'll re-establish and it'll start relearning like the PID loop. Okay? Is that in there? The controller's behind here. So it's like it's its body itself. So right now we'll just turn this off. So we'll turn off the pump, turn off the power. That's gonna be this controller down here. Okay? So we have a control transformer up here. High limit controller, controlling unit. That's going to be a timer, an off delay timer over here for the pump. Okay? And then the pump contactor over here. Pretty basic setup here.
Interlock door?
Yeah, I was going to say there is an interlock door, so if you do have the door open, you won't, even if we try to turn on power, the unit won't boot up. Okay? It is a 120 volt unit. Okay, the door switch made in the unit. So this lets us know we do have power to the switch. Now we turn it on, we get all of our lights, we're going to boot up the controller. Once it's booted up and it's turned on, you can have this in auto before that. So right now the controller's still booting, so it's not turning off the pump quite yet. We just heard the contactor pull in, so now it's calling for the again, there's redundant units here. So for the domestic side, right here, we have our domestic cold water in to the bottom of the tank. It's insulated because it is part of our return system, okay? Our domestic hot water return system. The domestic makeup is part of that right now. So if you needed to work on the unit, you can shut this valve right here. This would be your main cold shut, and then the main hot shut off is going to be the one up on the top, and that would isolate everything inside of it. If you did need to drain it, just make sure you turn off the unit, the power to the unit, because we do have a circulating pump inside as well. Okay. So that's the domestic water side. The heating hot water side, we have a balancing valve here on the return. If you're just trying to stop flow to the unit, you can shut this valve, right? This down here. But if you're trying to drain the heating hot water side of the unit, close this, and now we won't have heating hot water flow, but we can't drain it yet. Okay, if you got to drain it, you got to shut the valves off, turn it up there. Okay. But if you're just trying to stop flow on the heating side, if the unit's like somehow the control valve's not working, you shut that valve. Does that make sense?
Yep.
Okay. There is a balance. It's an automatic balance valve. They're 150 GPM, so 150 GPM per heat exchanger. Okay. We don't expect them to be on full open all the time. Strainer. There's a strainer on the heating hot water side up here, and then there is a strainer down on the domestic side of the bottom over here too. Okay. So if you're not making your temperatures and the valve is open, we can start looking at a strainer over here. Okay. And if that was good, we'd want to check the strainer at the bottom too. There's drains down at the bottom of the tank. I'd recommend like quarterly blowing those down at the bottom. I did miss drains at the bottom of our heating hot water pumps. There's drains at the bottom of the suction diffusers. Those would be good to blow down quarterly as well. Okay, so now leaving, we're in auto, all the controllers powered back on, we didn't shut any valves, the valve is open. Okay, so we can walk away from this now that we've touched with it. We've done a visual inspection to make sure everything's good and back in all the appropriate positions. So for domestic hot water leaving, remember we're maintaining 140, so if we send out 140 to the building, we can burn people. So moving on over here, our domestic water comes out and it goes through our mixing valves over here. And we have our cold water as well. Cold's going to be on this side over here, hot's on this side. And then our mixed water outlet right here, 120 degrees. It's like 118, okay? I always try to shoot like a couple degrees below your set point in case the mixing valve overshoots a little bit. Just a couple, so they're set for 118, okay? That setting is adjusted by this up here. These do require maintenance. I would say quarterly again, inspect them. Just know, like right now this temperature is a little below, but we don't know the loading of the building right now. And then we don't know if the circ pump's running yet, okay? So we'd have to create a load to know if we're reading right, okay? So we can do that here by closing this valve. We have redundant mixing valves, okay? These are in parallel with each other, so you can service one and have some capacity to the building. I would say at least every 6 months, I would verify the setting of this. So by that, we can shut this valve right here, our leaving valve. We can stick a hose bib adapter in here and run this to a drain, and then we can open this and we can actually check our setting, okay? That way you're controlling the water that's flowing out of the device, okay? We want to follow the manufacturer's guidelines on GPM. I believe it's 15, but the model number of the unit is on top of this nut right here, we can search for that information or use the O&M manuals that are turned over to search for that. Probably going to be easier to look the information up on the internet. Just be very careful looking up information on the internet. There's a lot of information. You just want to make sure you're on the right piece of equipment. And that would be true for any of the equipment anywhere. And anytime you try to use the internet to get your information, it's super easy to think you're in the right manual, but you're looking at a very similar manual for the same piece of equipment. Okay. So again, the valve's off. We're checking water to the drain. We can check our set point. At that point, you can still verify the calibration of your thermometer too with the handheld that you know is accurate. You know, you can measure that at the water source too to make sure that your thermometer is good. Okay. Once we're done, we'd close the valve and we can open this back up for service. Just depending on the flow through the building and if the pump's running, the circulating pump is running or not, the temperatures might be a little bit different. Like right now, we have a little bit more flow through this unit than that unit, okay? But they're both set up for 118. So as the capacity of as the building's capacity increases, it will flow water through both systems, right? Any questions on mixing valves? Okay, so this building's so big that in no load conditions, we have a domestic hot water return loop. So under no loads, we have a circulating pump over here. It's drawing water back from the building, okay? When we get up higher, I'll show we have they're Khalifi Temputrol balancing valves, so they're off temperature. Have you ever experienced balancing valves off temperature? No. So this one has a bellows inside of it, and the bellows can expand or contract depending upon its temperature. Okay? All of them are set at 110 degrees, 105. We'll have to look when we get up there. So there's a temperature setting that they're set to. They're all the way counterclockwise, the lowest setting that we can go to. I think it's actually 105. It's 105 up there and it's 110 down here. Okay? So if it cools off, the bellows shrinks down and the orifice gets bigger, so more water goes through that balancing valve, okay? As that hot water then runs through that balancing device, it expands back out and it closes that orifice and lets the water go other places. So it's a self-balancing system, okay? And that gets drawn back through here. So this is our return from the building, comes back, okay? And we're pumping up. Now this is where we're balanced. We have a line that goes back to the cold of the mixing valve, okay? We have another line that keeps going back up, back into the cold makeup to the storage tanks. So roughly, when we have this return with the mixing valve, about 80% of the water comes back through your mixing valve, okay? And about 20% goes to your heating source. Then it gets fine-tuned from there, okay? We want to always maintain 120, like the 118 leaving the mixing valve. And again, this is under no use. So if people are in the building using water, this test can't work, okay? You have to make sure that nobody's using water in the building when you're looking at this part of the system with running the circ pump. But what you would do is you would open or close this balance valve, or there's another one way up high over here on the line. So if we know nobody's using the water and the temperature going out, what I would do too is only use one of the two mixing valves when you're doing this. If the water going out is 110 and we're shooting for the 118, with the pump running, that means we have too much return water, or the return water is not at temperature yet, okay? So we can either close down this valve to push more water through the 140 loop, or open the 140 loop up, just depending on positions. Does that make sense? Have you guys had to deal with this part before?
Nope.
Okay, so do you have mixing valves other places? And there's not this split between this, or we just never looked at? I'm just wondering.
No, it's just water in through the mixing valve and then water out to the building.
Okay.
And then there is a return with a circuit center on it that just like loops back bypassing the storage tank?
It would depend how the building's piped. If it's, one pass, you probably don't need all this. We do have multiple sources, but again, just depending. Right now, the system's balanced for that 118 under no loads. Because again, the CERT pump is only when nobody's using water. If somebody's using water out of fixture, you're mixing your hot and your cold together, and that's where this setting comes into play, okay? Because this adjustment is only made with flow. Once you've set it, then with no flow, and when I say no flow, it's no fixtures open in the building. You're gonna have flow by the pump. You have to make sure the pump's running. Then you would fine tune, like I said, the 2 balance valves to make sure you're always maintaining that 118, okay? Does that make sense? Okay. Any other questions on the domestic for in here? The domestic is controlled. This is your starter for the domestic. So there's a contactor, overload, and a transformer that runs up to the aquastat right here. Okay. Local switch right here for the starter. Okay. This is 480. It's a 48 volt unit. Okay. The last thing we have in here is the booster pump skid. Hi guys, Mike again, A.O. Reed. We're still in this mechanical room on the first floor. Cal State University Fullerton, the new housing building. The last thing we need to talk about in here is our domestic water booster pump skid. Okay, so it's a domestic cold booster pump skid, but then that also feeds cold and hot. Okay, so we're boosting the water pressure on the cold side first, and then it feeds both hot and cold in the building. Okay, so this is a Grundfos unit. Right now the unit is in sleep mode, so just to wake it up we can press the home button here. We want to make sure the disconnect, this is the main disconnect switch right here, make sure it's on. We've woken it up, this is our main screen in the status mode right here. Right now we can see that we're in system normal and all the pumps are stopped, all the pumps are in auto. Okay. To make an adjustment here, we're going to use the arrow button and go over to operation. This is where our set point, we're set at 70 psi. Okay, that gives us like 30 pounds or so up on the roof for the engineer. You can make an adjustment here, just make sure this booster pump skid has an expansion tank on it, which is over here. This expansion tank on the left goes with the booster pump skid. There's another one on the right, which is the expansion tank for your closed loop heating, domestic hot water system. Okay, for thermal expansion for the heating on the domestic hot side. The expansion tank on the right is set at 70 psi because that's our building set point. Okay, it's even because it's for the closed loop side of it. The expansion tank on the left is set at 50 pounds, which is 70% of this set point. So that way, when this hits its set point, it pressurizes the tank and there's stored energy in that tank. So if someone opens like 1 or 2 fixtures, the pressure in the tank comes out of the system instead of trying to turn on a pump. Okay? So the tank on the left is for the booster pump skid. We want 70% of your set point, which is 50 pounds. Okay? Have you guys checked expansion tanks before? Do you know how to check them?
No,
Let me review it my way. So how to check an expansion tank? We're going to want to shut off our shut-off valve up there. Okay, so we shut off our valve. We need to make sure we drain the pressure off the tank. Okay, so we could take this plug out right here. I would put a hose bib adapter and run it to a drain over here. These things, especially this one being a lower set point than your system, it's going to hold more water. Okay, so you'll run your hose to the drain, you'll equalize, you'll get all the water pressure out of the tank. Okay, then you can take off this nut right here, the Schrader cap, and you can put an air chuck on it. Okay, the key is that the valve is off and you've let off the water pressure. Because remember, we talked about it right here, right? This is 70% set point of the system. So if the water pressure was 70, pushing it on the 50, if you check, this is going to read 70. That's why you want to always eliminate the water pressure off the system. Then you know your actual charge pressure. And when we charge these tanks, if you somehow have a air dryer system attached to an air compressor, you could use that. Dry air, we use nitrogen. It's easier for us to use nitrogen, okay? So we want to charge these with nitrogen. It's an inert gas. It doesn't change pressure as easily as air does, depending on its temperature, okay? 2 expansion tanks. We said that what that's for. Once you're done checking your set point, put the cap on, close this valve, and then you can slowly open your shut-off valve, okay? Back to the skid. Again, we've moved over to operation mode. We're on 70. If we press OK, it's flashing. I can change it, okay? So press OK again, locks it back in at our new set point, okay? Now we can use the up and down arrows right here. We're going to go down, operating mode, normal, okay? Normal is checked. We need to go down to stop mode. So I just turned it off. So now if we go back to our main display, we can press home. Now we see our system is in stop mode. So now the unit will not work. We're not controlling the pressure anymore. Okay? Go back over. We're going to toggle the white bar back up to normal. Now the system itself is back in normal, controlling all pumps to set point. Okay? Go down further settings. We don't want to change the